Hello, this is Miss Frankie. I'm going to be talking about 3.3, which is area models and partial products. This lesson is an expansion from what we worked on in Chapter 2, where we learned how to draw models of, multiplication problems like 13 times 6. When we drew the model of 13 times 6, I broke 13 apart in expanded form. And then I drew a rectangle. Fix that one there. I drew a rectangle to show 13 across and 6 down. And then I broke my 13 into a section of 10 and a section of 3. And then, using this model, I multiplied 10 times 6 and got 60. And then 3 times 6 and got 18. And then I added up these partial products and ended up with my answer of 78. So today we're going to be doing the same idea, only we're going to be using 2-digit by 2-digit problems. So if we start with the problem 21 times 25, I'm going to break up my numbers 21 and 25 in expanded form. So I have 20 plus 1 is 21, and 20 plus 5 is 25. I don't need that just yet, but it's going to be beneficial once I make my problem. So I'm going to make a grid, and the students have grid paper to use today. To save some time, I'm just going to draw a grid out. So I have a grid of 21 by 25. Well, then I'm going to take my 21 section and I'm going to split it into two parts, a part of 20 and a part of 1. Then I'm going to do the same for my 25 section. Now this one is one that's going to go across. So 25 splits into 20 and 5. So now, using the same idea I did on Chapter 2, where I just found out where the numbers met, I have 20 times 20, which is 400. And then this guy continues on here and does 1 times 20, which is 20. And then this 20 up here continues on down. I'm going to circle him so I don't forget him. Circle that one. Then these two, 20 and 5, meet here, and so this is 20 times 5, which is 100. And then he continues on. 5 times 1 is 5. All of these circled numbers are my partial products. They're part of the answer, but not quite them. So I take all of the numbers, my products, and I add them all up. And when I add them up, I'm going to get 625. Or not 600, wow. 525, my bad there. Now, I know some students were struggling with how I knew that these met in these two blanks, or how 20 and 1 met here. The best way to explain it is with a grid. They should notice that this should be 20 going across and 20 going down. So this whole square is 20 by 20. Then this square over here, and I know I'm getting all sorts of crazy lines, would be 1 by 20. Let me use a highlighter here. This is going to be 1 going across by 5 down. And then this one would be 20 going across and 5 down. So each square is separate, and then I add them all up to equal my number. So looking at another problem, I have 16 times 14. Again, I'm going to break up those numbers into expanded form. So 16 is 10 plus 6, and 14 is 10 plus 4. I'm going to draw my big model. The big model, again, is the main problem. So 16 going across, 14 going down. Then I separate my 16 into their two parts. I have my group of 10 and my group of 6. Then my 14 is also separated, and I have my group of 10 and my group of 4. So now I have this square, or this rectangle, sorry, which is 10 times 10, which is 100. And then, change my color here, I have this square, which is 10 times 6, which is 60. And then I have this one down here, which is going to be 10 times 4, which is 40. And finally, I have my last little rectangle down here, which when I look at my numbers that meet, I'm going to have 6 times 4, which is 24. And I take all of my partial products and I add them up. And when I add them up at 10, 12, 224 is the answer to 16 times 14. All right, if you have any questions, please don't hesitate. I cannot talk tonight. I apologize. Please don't hesitate to let us know. And we will be using this kind of partial products for the next few lessons. So making sure that the students know that these are part of the final answer and adding them up to get the full answer. Have a good evening. Thanks.